Most people get this wrong. They think the reason things can't go faster than light is because light is fast and everything else is slow. That's not it at all. That's not the real reason. The real reason is much more fundamental, much more interesting, and it has nothing to do with light being special in the way you might think. Let me start by telling you what the speed of light actually is. It's about 300,000 kilometers per second, or if you like miles, it's about 186,000 miles per second. That's a huge number, right? But here's the thing, that number only matters because we picked meters and seconds as our units. If we used different units, that number would be completely different. So that number itself isn't what's important. What's important is that there is a limit. There's a cosmic speed limit built into the structure of reality itself. Now, here's what I want you to imagine. Imagine you're in a car on a perfectly straight road and you step on the gas. What happens? The car goes faster. You step harder, it goes faster still. Simple, right? Now imagine you're going really fast already, say 100 miles an hour, and you step on the gas again. You go up to maybe 120. The acceleration is still there. You're still pushing with the same force, but you don't get as much speed increase. That's something you already know about the world. As you go faster, it takes more effort to go a little bit faster. Well, special relativity says something very similar happens to everything, but the effect gets more and more pronounced. When you're going slow, regular speeds, nothing unusual, you barely notice it. But as you get faster and faster, approaching the speed of light, this effect becomes enormous. You need exponentially more energy to go just a tiny bit faster. At the speed of light itself, you would need infinite energy, infinite. And since we don't have infinite energy to give anything, nothing with mass can actually reach the speed of light. But here's where most explanations stop, and here's where they're a little misleading. They say, well, the mass of the object increases, so it gets harder and harder to push it. That's true, but it's not the deepest explanation. It's like saying a car can't go faster because the friction keeps increasing. Yes, that's true, but why is there friction? Why is the universe designed that way? The real reason, the truly deep reason, is something much more beautiful and much more strange. And to understand it, you have to understand what space-time really is. Einstein had an idea in 1905. He said, look, space and time aren't separate things. They're not two different dimensions of reality that just happen to exist side by side. They're unified. They're part of one fabric together. We call it space-time. Now, what does that mean? Think about this. In everyday life, we can move through space any way we want. I can go north, I can go south, I can go east, I can go west, and independently of that, time just flows forward. I don't get to choose that. Time always goes forward at a constant rate for me. But relativity says something strange happens when you move really fast through space. Time starts to flow differently for you. Not much when you're going slow, but measurably when you're going fast, and dramatically when you're going very fast. Here's the key insight. A mathematician named Hermann Minkowski, he was actually one of Einstein's professors. He looked at Einstein's equations and he realized something profound. He said, listen, everything in the universe is moving through space-time at the same speed. Everything. All the time. That speed is the speed of light. Right now, sitting here stationary, you're moving through space-time at the speed of light. Now wait, you're saying I'm sitting still. How am I moving at the speed of light? Well, you're moving through time. You're moving forward 1 second per second. And in space-time, that counts as motion at the speed of light. The whole system is set up so that the total speed through space-time is always the same for everyone, the speed of light. So think of it like this. Imagine you're driving across the desert, let's say Utah's Bonneville Salt Flats. It's flat, it's huge, and imagine your car has a governor on it, a limiter. No matter what you do, it can only go 60 miles per hour, period. That's the maximum. Now, if you go due east at 60 mph, you're not moving north or south at all. You're going all 60 miles per hour in the east direction. But what if you want to go northeast? Well, you've got to split that 60 mph in between east and north, maybe 42 mph in east and 42 mph in north, or something like that. But the total is still 60 mph. It's exactly the same thing with space-time. You've got a total speed limit through space-time. That limit is the speed of light. Some of your motion is through space, and some of your motion is through time. If you're standing still, no motion through space, then all of your motion is through time. You're aging. Time is progressing for you at the maximum rate. But if you start moving through space really fast, you have to reduce your motion through time. And that's why time slows down for you when you move fast. That's why moving clocks run slow. You're shifting your motion budget from time to space. and the total stays the same. Now here's the thing. The absolute maximum amount of motion you could possibly have through space is if you moved zero through time. If time completely stopped for you, at that point, you'd be moving through space at the speed of light. And that's exactly what photons do. Light particles. Photons have zero rest mass, so they move entirely through space and not through time. That's why they travel at the speed of light, and that's why nothing can go faster, because you can't move less through time than zero. You can't stop time more than completely. Let me explain this another way, that might be clearer. Space and time aren't what we usually think they are. We think of space as something that contains things, and time as something that passes. But in relativity, they're more like two directions in a larger space, a four-dimensional space. You can move in the x direction, the y direction, the z direction. That's regular space. But you can also move in the time direction. And just like in my Utah driving example, your total speed through all four dimensions is constant. There's also something else that happens, and it's related to this geometry I'm talking about. When you move really fast through space, distances contract in the direction you're moving. The universe looks squished, and time dilates. It stretches out. Things happen in slow motion for you. These aren't tricks or illusions. They're real effects baked into the geometry of space-time itself. Now you might say, okay, fine, so I can't go faster than light. But what about my message? What about sending information? Can't I send information faster than light? No, and the reason is causality. Everything has causes and effects. Your cause precedes your effect. If information could travel faster than light in one direction, then there would be another observer, someone moving in a different direction for whom that effect happens before the cause. And that violates the fundamental structure of the universe. We've never seen causality violated. We've never seen an effect happen before its cause. And this cosmic speed limit is what protects that. There's another way to think about the speed limit too. When light travels through a material, like glass or water, it slows down. It goes at 2/3 the speed or 3/4 the speed or whatever. But you can still accelerate particles beyond the speed of light in that material. And when you do, something strange happens. Cherenkov radiation. The particles are going faster than light in that medium. So they produce a shock wave like a sonic boom but with light. And that shock wave travels at the speed of light, the actual cosmic speed limit. Even in materials where light is slow, you can't beat the cosmic speed limit with any kind of information or energy. People sometimes ask me, well, couldn't we just build a better spaceship? Couldn't we just push harder? And the answer is no, not in any way that helps. You could build a spaceship and accelerate it to 99.9999% of the speed of light, anything you want. But that last little bit to actually reach light speed, it gets exponentially harder. You need more and more energy. At the speed of light, you need infinite energy. Now, there's something else that happens at these extremely high speeds that's worth understanding. Your mass doesn't actually change. That's a common misconception. But your energy increases. And energy is equivalent to mass, right? E equals mc squared. So as your energy increases, it's as if you're harder to push, harder to accelerate. You become effectively more massive to the universe around you. Some people have wondered, could there be particles that naturally travel faster than light? They've given them a name, tachyons, hypothetical particles that are always faster than light. And mathematically, you can write down equations for them. They don't contradict mathematics, but they would contradict reality. They would violate causality. They would allow time travel. They would let you send a signal into your own past. And we've never seen any evidence that they exist. I want to come back to something I said earlier because it's really important. The speed of light isn't actually about light being special. Light happens to be the thing that travels at this speed because it has no mass. But the real cosmic speed limit, the thing that matters, is just a conversion rate between space and time. It's part of the structure of reality. It's not a speed limit on light. It's a speed limit on causality. It's a speed limit on information. It's a speed limit on energy. Light just happens to travel at that limit because it's massless. In fact, a better name for the speed of light might be the speed of causality or the speed of information, because that's really what it limits. Anything that can carry information, anything that can be a cause, cannot travel faster than this speed. Now, what does this mean for your everyday life? Well, not much. The speed of light is so incredibly fast compared to anything we normally deal with that it doesn't matter. You never feel this cosmic speed limit in your normal experience, but it's there. It's the reason the universe works the way it works. It's the reason causality works. It's why effects follow causes. It's why you remember the past but not the future. And here's something really mind-bending. The fact that there's a finite speed limit for information means that the universe has a kind of cosmic speed limit on communication. If I want to send you a message from across the galaxy, it takes time. It takes a lot of time. The universe is far too big for instant communication. And that's not because we haven't invented the right technology. It's because the universe itself doesn't allow it. It's built into the fabric of reality. That's why I said at the beginning that most people misunderstand this. They think it's about light being fast. They think it's about engineering limitations. They think maybe someday we'll invent a faster-than-light drive. But the truth is much more profound and much more interesting. It's not about light. It's about space-time. It's about the relationship between space and time. It's about the structure of cause and effect. And here's the thing I find most beautiful about this. This isn't just some rule that was handed down that we have to follow. It's not like the speed limit on a highway, which is arbitrary. You could theoretically change it if you wanted to. This is something that emerges from the deepest structure of how reality works. If you have a universe where space and time are unified into space-time, if you have a universe where the laws of physics are the same for all observers, if you have a universe with causality, then you automatically get a cosmic speed limit. It's not a choice. It's a necessity. And that limit happens to be the speed of light. Not because light is special, but because that's the rate at which space-time is woven together. So the next time someone asks you why nothing can travel faster than light, you've got a better answer now. It's not because light is fast, it's because space and time are connected. It's because causality has to make sense. It's because the universe is built from space-time, and in space-time, there's a universal speed limit for everything. And that, to me, is far more interesting than just saying, because light is fast.